Okay, so today we're going to learn about covalent bonding, and we're going to think about covalent bonding in depth. Now we've already learned the definition of a covalent bond, so I'll go ahead and put our lecture title up. So, covalent bonds occur when two nonmetals share one or more pair of electrons. Okay? So we're talking about at least two electrons shared between two nonmetals. Okay? And these electrons have to be shared in multiples of 2. So an important fact to remember is that this sharing, or this electron sharing, allows both nonmetals to achieve noble gas valency. Okay? So what that means is it allows both nonmetals to be able to access the same number of valence electrons as their nearest noble gas. Okay? So we're going to start with an example, right? And here's an example. Our example is water. And we went over this last week, but it's important to look at again in depth. So if we write the electron configuration for hydrogen, we already know that it's 1s1, okay? First row, S block, first element, 1s1, that's hydrogen. And so naturally, hydrogen has one electron period, so it's got one electron in its outer shell. So we can draw our Lewis dot structure, and we'll talk more about those in a minute, for hydrogen like this, okay? And then oxygen's over here, right? So we go, to get to oxygen, 1s2, 2s2, 2p4. Okay, so 1s2, 2s2, 2p4. Okay, that's oxygen. So you might want to ask yourself, how many valence electrons does oxygen have? Well, 2 plus 4 equals 6. So we can draw 6 dots, 1, 2, 3, 4, 5, 6, okay? 6 dots to represent our oxygen, okay? And when we draw these structures, and we'll talk about this more again in a bit, we only pair when we have to, okay? So we would draw free dots on every single side, but then we'd pair 2 of them, and we'd leave 2 open, or sorry, unpaired. And those unpaired electrons are the electrons that can bond, okay? And to be fair, I butchered that explanation just a little bit right now, so if you're confused about that, don't worry. But we'll go over it at length when we get to an extended discussion about Lewis structures. For now, that's all the mention that I'll make of it. But we have 2 unpaired electrons, so oxygen can make 2 bonds. It can make a bond to this hydrogen, and if there's another hydrogen present, it can bond to that hydrogen, okay? And so these 2 electrons that are unpaired here don't want to be unpaired. So this hydrogen will move right in, this hydrogen will move right in so that these 2 electrons are not unpaired. And the full Lewis dot structure for water is HO, H, like that, okay? So central to all of this is being able to understand immediately and quickly, right, which is redundant, how many valence electrons any given atom might have, okay? And so when we look at oxygen, we can go through the full electron configuration for oxygen to get the number of valence electrons, and we can say, okay, the inner shell is shell 1, the outer shell is shell 2, so 2 plus 4 gives us 6 valence electrons, and then we have our 6 dots, right? We can do that, but there's an easier way. just by looking at the periodic table. We can count actually from the shell that the oxygen is in. Okay, so the oxygen is in the second row. That means its outer shell is shell number 2. So we can count from left to right. Let's do that, okay? Ready, set, go. 1, 3, 4, 5, 6. Okay, so once you get over to oxygen and you say 6, right? You've got 6 valence electrons for oxygen. Okay, and you're going to draw 6 dots around it. And so we're going to practice finding the number of valence electrons for some nonmetals, and we're also going to practice drawing Lewis dot structures. So a really good way to do that is to draw Lewis dot structures for the diatomic gases, okay? So Lewis dot structures for diatomic gases, okay? And these guys end in gen. A little better job of writing gen on the board. Gen. And ein. Okay, like that, ein. Okay. All right, so here we go. So let's take a look at which atoms make diatomic gases, okay? So remember, the elements that make diatomic gases end in gen and ein. So follow along with me. This guy is hydrogen, okay? This guy is nitrogen, oxy, okay? Now fluor, ein, chlor, brom, io. Yes, okay? So that's the deal, right? These guys make diatomic gases. So what do these things actually look like? Well, let's start with hydrogen, right? So we'll go formula, and then we'll go structure. Okay, so the formula for hydrogen gas is H2, right? What's the structure going to be? So the structure is going to be H with one valence electron, H with another valence electron. These two come together, okay? And I'll draw a reaction arrow, because there actually is a way to make this reaction happen, okay? You can use light to dissociate the bond between two hydrogen atoms, and then they'll just naturally come back together to create hydrogen gas, okay? So you can actually make that happen if you want. So those two hydrogen atoms come together to form hydrogen gas, okay? And this is the first time you're seeing a reaction arrow. You'll get used to it, okay? Well, we're going to get there pretty soon. Reactions are really interesting. So, okay, this is hydrogen gas. Now, what about, let's start right over here with this guy, number 9, so F, okay? Fluorine gas, F2, okay, also occurs. Fluorine gas also occurs as a diatomic gas. So what's going on here? So in order to get hydrogen, we had to have the number of valence electrons. Well, that was 1, right? And then we put this thing together and we said, okay, hydrogen wants to be like its nearest noble gas, which is helium. Okay, so helium has 2 valence electrons. Now each hydrogen has access to how many electrons here? 2. Okay, so they're happy, just like helium. All right, so fluorine gas, right? So fluorine, let's figure out how many valence electrons fluorine has. Let's count from the left side, okay? Ready, set, go.
1, 2, 3, 4,
5,
6,
7. Good. So 7 valence electrons for fluorine. So how many dots are we going to draw around each fluorine atom?
2.
2 dots? How many dots do we draw? So we draw, like for oxygen we had 6 valence electrons, so we drew how many dots? 6. So fluorine's got 7 valence electrons, so how many dots do we draw? 7. Seven dots, okay? So we go F. Okay, 7 electrons there, plus another F. And then I draw this dot up here and this dot down here so you can see how they fit together, okay? Just visually like puzzle pieces. You don't have to do it that way, but I always do. And then that gives us F. Okay. Here we go. Right? And that's our structure for fluorine gas. Now here are some important points, okay? Some really important pieces of information. Electrons between two atoms okay? And we're talking like these electrons, okay? Are considered bonding electrons. And I'm going to go semicolon here. The other electrons are non-bonding, okay? Or lone pair electrons, okay? And so we're talking about these guys, these guys, these guys, these guys, these guys, and these guys, okay? So those other electron pair that are not in between the two letters, okay, are the non-bonding electrons. So notice, each fluorine has how many unpaired electrons? One. This guy's got one unpaired electron, this guy's got one unpaired electron. So how many bonds does each fluorine atom make? One, okay? You make as many bonds as you have unpaired electrons, so boom, right? Because the unpaired electrons are not happy, okay? Or atoms themselves are not happy with unpaired electrons. So they try to pair those electrons up, right? That's the scoop. So these guys say, hey, I need an extra one, I got an unpaired electron. This guy's like, yeah, I got an unpaired electron too. And they're like, okay, let's commiserate. Boom. They make a covalent bond, okay? Those two electrons are shared between the two atoms. These other electrons are lone pair electrons. They're non-bonding. But those two electrons in the middle are absolutely bonding electrons, okay? And if we haven't already noticed, we'll just put it down, okay? Each dot represents one valence electron, okay? Each dot represents one valence electron. That's very important. That's how Lewis structures work. Okay. And so, I'm going to erase the left side of the board, and we're going to do some more practice. With Lewis dot structures for diatomic gases, okay? So we're going to go with this one, formula and structure. Okay, so our next diatomic gas is going to be chlorine gas, okay? Cl2. What's the structure going to be for chlorine gas? All right, so really quickly, just take about 10 seconds with your group. How many valence electrons should chlorine have? Okay, how many valence electrons for chlorine? Go. Raise your hand if you can hear me, please. All right, so how many valence electrons for chlorine? On the count of 3, 1, 2, 3.
7.
Good job, okay? So chlorine gas also looks just like fluorine gas, right? And I shouldn't at this point have to tell you that bromine and iodine in their gaseous forms are going to look the same. But what about nitrogen and oxygen? And what about other combinations of elements? Those are things that we can discuss next time.